C# includes a #define directive that lets you define compilation symbols. You can think of a compilation symbol as a kind of metadata variable that lets you compile code in different ways for different scenarios. Except that the compilation symbols don't have a value associated with them. You use them by virtue of whether they exist or not. In other words, whether they are defined or not. For example, maybe you want to include some code that logs various events in the debug builds of your application, but not in the release builds that you install on user machines. Or maybe you have a free version of the application and you don't want to include some functionality that only paid users get. In this case, you can compile two different versions of the application. In fact, most Visual Studio projects include a debug build profile that defines debug and trace symbols. These symbols are not defined in code, but in a project's property pages under the Debug tab. So if I come over here to Solution Explorer, I can get to that by right-clicking on the project name and selecting Properties, or alternatively, I can just double-click on Properties. Now, the last time I had this project open and I opened the project property pages here, I was on the Build tab, so Visual Studio remembered that and took me right back here. All right, so by default within the Debug build, these two checkboxes are checked. And this causes the compiler to include the debug constant and trace constant. So those are compilation symbols. And then if I wanted to find any of my own, I could list them here within this text box. And so what happens when I have either or both of these checked and I have any other symbols defined here is that Visual Studio adds a /build argument to the compiler command line, and that's what causes the compiler to define those constants. And it's important to understand that when you do it as part of the build like that, then these are going to apply to all code files throughout the entire project. And again, this is per project. I can have multiple projects in the solution. If I wanted those symbols in other projects, I would have to open the property pages for those projects as well. Okay, so I'll close that. But then you can also define a compilation symbol in code. So here I'm using the #define preprocessing directive in order to define the symbol or the symbol constant. Now, all of these kind of definitions within code files have to occur before any other code in the file. And its scope is only going to be within this code file. So if I have a couple dozen other C# code files within the application, this symbol constant is only going to appear within the program, or only going to have effect within the program.cs file. So that's the difference between defining them in the project pages and as a statement here within the code. Okay, so as I've defined here, symbol is not going to appear or have any effect in any other code file. So again, that's the major difference between defining a symbol this way in code and as a compiler build setting. All right, then you can also undefine a symbol. So if you recall, in the property pages, I had the checkbox checked to define the trace symbol. Here I am undefining it for this code file. The statement has no effect on any other code file in the project, but only within this file. So as far as the code in this file is concerned, trace does not exist. It's undefined. Okay, and again, that needs to be at the beginning of the code file as well. So all of these preprocessing directives that define and undefined symbols have to be before any other code appears. Okay, then I can come down to directives. I'll just do the direct way of right-click on that and go to definition. It takes me real quickly down to that code. Then I can use an if statement, which is another preprocessing directive, to check to see if symbol is defined. If it is, then I execute whatever code exists between the if and the end if here. And I have a single statement, but I could have a whole block of statements if I wanted to. Okay, then this code is going to execute whether or not symbol was defined, because it's outside of that if block. So it's just a conditional block, sees if that exists. And keep in mind that these symbols, you use them by dint of their existing, not that they have a specific value. Okay, and then this code block shows something a typical way that you might use the debug symbol. The code displays some diagnostic information, and it writes it out to the console window. Although in a real application, you're more likely to record this information in some log someplace, in the Windows application log or a database or a XML file on disk, someplace else, but keeping the application symbol. Okay, so the idea here is that in a debug build, you want to see that the Spitzblat method started executing, and it records the time that it started executing. So we have that one conditional. So if it's debugged, that code is going to execute. If debug is not defined, if this is a release build, then this code is not even going to exist within the assembly. And then I have a closing one here. I have another conditional block, and I write out this, that it finished executing the Spitzblat method. Probably should have picked something a little bit easier to pronounce. And again, displays the time. Okay, so this way, in debug builds, you can see that the Spitzblat method started and finished and the time of each. Now, there are also #else and #elif, which is else if. So you can use those directives for more complex conditional structures. So you can, if debug is defined, else you do something else if you do something else. So you can create some very sophisticated blocks of conditional statements. All right, then another pretty cool thing that you can do with compilation symbols is to define conditional methods. So the system.diagnostics namespace in the .NET framework provides a conditional attribute that provides a special compile time behavior, and you can see that right here. So what it does is any method that's annotated with this attribute will only be compiled if the compilation symbol is defined. So in this code, the compiler is going to strip away the Spitzblat method from the resulting IL code. Another way of saying that is it won't compile it in if debug is defined. Actually, let me change that. I intend this to be debug. Right there. Okay. So if debug is defined. Okay, so this method won't even exist. But what's even cooler is that I put this attribute here. This method isn't included. Normally, that would mean that this method call would fail because I don't have this defined method. But what this conditional attribute does in addition is it removes the method and it removes calls to that method. So this method is not going to exist. Okay, so as I've got the code written now, when I made that correction, I'm going to run the application. Okay, and I'm going to press F for the directives. And as you can see, symbol is defined. So that's coming from this. So symbol is defined at the top of the code file. So it writes that out. And then it's executing this, performing the Spitzblat method in program.cs at 11:19:15 a.m. in the morning. And then it executes the Spitzblat method itself, which just displays inside Spitzblat. And then it does the second statement that here is within that conditional debug statement there, that it finished the Spitzblat method in program.cs at 11:19:15. Now Spitzblat, all it does is write that out. It's a very fast method, so there's no difference in the time there. Occasionally, if you run this enough times, you might see this be 15 and 16, but that's going to be pretty rare because it just takes a few microseconds or a few milliseconds to execute. And then it displays press any key to continue. Okay, so this code appears because the debug symbol is defined. Okay, so I'll hit enter to get out of that and X to end of the program execution. But now what I'm going to do is I'm going to change this to trace. Okay, recall that in the top of the code file, I undefined trace. So even though for the project it's defined within the project properties, down here in the code, it's not defined. And so, because it's not defined, Spitzblat is not going to be in the code. All right, so I'll run it again. This method call is still there, But nonetheless, when I hit F, I'm not inside Spitzblat because it didn't execute, and that call didn't execute, but I get these two debug statements because the debug symbol is still defined. Okay, so in a real application, it'd probably be better to put these statements inside the Spitzblat method, but for sake of demonstration, I included them here. Okay, but be very clear that by default, most .NET projects created with Visual Studio define that trace constant, but the trace symbol is currently not defined because I undefined it at the top of the code file. And in fact, all of these techniques are the same thing that .NET itself uses to implement various debugging and tracing features, including code that it executes when each of the debug and trace symbols are defined. But you can also use them within your own code. You can also produce your own compiler errors and warnings with the pound error and pound warning directives. When you compile your code, these appear in the errorless window in Visual Studio, along with any messages generated by the compiler. So it's a real handy technique for essentially instrumenting up your code with various kinds of messages where you can test for different kinds of conditions and then display messages to the developer. A typical way to use these error and warning directives is within a conditional compilation symbol statement like I have here. Now, I'm basing it on a compilation symbol, but you can include other conditions as well. So what this is going to do is that if the trace is defined, if the trace symbol is defined, it's going to display this warning that says the code in the sample application may perform poorly when the trace flag is set. Notice that I have the directive. It's indented. Visual Studio automatically formats code files with most directives way left justified, but I can indent warning. And also notice that the string here, because a preprocessor directive statement has to be on its own line, doesn't need quote delimiters. If I included double quotes around this, those would appear in the output message. Okay, so if I go back up to the top of my code here, notice that I've undefined trace. And so if I build this application, I'll build the solution. It succeeded, and I go to the error list. Notice that if I scroll up here so you can see that, notice that I don't have a warning that says the code in the sample application. That's because trace doesn't exist, and so I don't get this warning. But then if I go back up to the top of the code file and comment out that definition and then rebuild the application, and strictly speaking I don't have to do that step because the compiler is doing it behind the scenes, but just to make it clear, I can go to error list here, and now I get this warning. The code in the sample application may perform poorly when the trace set flag is set. So that's how you can use that, come back down into the code, within a conditional compilation. And in fact, because the code now includes that warning, I get this green squiggly line that's a warning, and it parrots that warning. Okay, by the way, I don't know of any reason why your application would perform poorly when the trace symbol is set. I was just using this as an example of using the warning directive. So don't be worried about using trace within your application. It's a real nice feature in order to get information about the performance and operation of your program. The last two preprocessing directives that I want to discuss here do nothing at all. The pound region and pound end region directives let you define regions of code that in the Visual Studio Code Editor you can use to collapse down to hide code that you're not currently working on. This makes it much easier to work with long code files. You can nest regions, and you have to pair a pound region directive with the pound end region directive, otherwise the compiler is going to complain. These directives let you define your own collapsible regions, such as to include only a few of the methods defined in a class. You can have as many custom regions in your code as you wish. They do nothing to affect how the C# compiler compiles the application. One of the nice things about defining regions is that you can include a text string with the #region directive. And that text will be visible when the region is collapsed to a single line in the code editor. So program.cs has two different regions defined. One for the main menu code here, so this includes the body of the code, and then just something random I did, a region around the first three methods. What I'll typically do is, say in a web application, is I might have a region around all of the events that are raised by the user interface within the application, and then a different region for all of the support methods that those user interface methods call. And that's a nice way to partition the code, because generally I'm working with one or the other kinds of methods, and that makes it real easy to collapse and get out of the way the methods that I'm not currently working on. Okay, so if I want to collapse the method, I just click on that little minus button over here in the left, and it collapses down and displays that text that appears. A nice feature is that if I hover the mouse over this, it shows me at least the first part of the code that is within the region. So I don't have to expand and collapse a region just to see if it is likely to have everything I want. Now there is a limit to the amount of code that it can display, but generally it's enough to identify what the region is. All right, then I can move over here and I have this other region that I can also collapse, and that's going to collapse and hide the first three methods. And that shows more of the code, but you can see at the bottom there that the assignment expressions method is cut off because there just isn't enough room to display it, at least in this resolution. But you can have a region that has thousands of lines of code within it, and in that case there's no way that you're going to see it all. But again, I can see, oh, it has the statement block and calc hypotenuse. No, those aren't the methods that I want, and move on to another method. Another nice thing is that if I turn on line numbers, I can go to Tools Options here, and I need to remember where this is. I believe that's under the text editor and General and all languages. Line numbers. Yeah. So I want to turn on line numbers for all the text editors for all languages, and that displays the line numbers over here in the left. A real nice feature to have, and normally I have it on in my regular development environment. But what's interesting here is that you can see that I have 15, 16, 17, and then I jump to 30, because whether the region is expanded or collapsed, this is line 30. So that way I have consistent line numbers over on the side here. And as you can see, I come down to line 32, and it jumps to this statement is line 71. So lines 33 through 70 are contained within this region that I've defined. Now you get this functionality of being able to collapse and expand things even without region, because the C# code editor lets you collapse code objects, things like classes and method definitions, without using a defined region. So for example, I could come up here and notice that I have that collapse symbol there. I can collapse that set of using statements to hide them and get them out of the way. And notice that because this is not a named block of code, I don't have a name over here. And so the editor just displays this ellipsis symbol, and I can hover over that and see the contents there. And notice even within that, I don't quite get them all. The using console menu at the bottom is a bit cut off. I can also collapse the namespace. This time it is a named object, so I get the name there, and I can hover over that and get the first few lines of what that namespace is involved. And if I come back over here, you can see that I can collapse the program, I can collapse the main menu, here's the region that I defined, and all of the methods have their own collapsible icons there. So I can collapse comments, and I can hover over that if I just need to see, oh yeah, that's what that does, that's not the method I need, and so forth. Okay? So there are a number of essentially container kind of objects like that. Almost anything that contains multiple lines of code or sections of particular kinds of code, like this using set of using statements, will you can collapse within the code editor. Now, always remember that regions don't affect your code, how your code is compiled at all. They're merely a convenience for organizing long and complicated files, making them easier to navigate and locate the code that you're looking for. You can still search for things, and any region that contains what you're searching for is going to automatically expand so that you can see the search results. And then there's also high-level support for working with outlining like this. Come down here to Edit Outlining, and the main thing is Toggle All Outlining. That now opens up everything. I can toggle it again, and that's going to collapse everything. So even if I expand this, all of the individual items are collapsed. So to drill down back into everything, I need to drill and expand everything. Or else, once again, come back up here to Outlining and Toggle All Outlining. Now, there's another item here called Edit Outlining Toggle Outlining Expansion, and I'll click on that, and it appears to do nothing. Well, that's because it affects selected code, and that isn't really obvious from the description. So rather than going back up to the menu, I'll hit Control-MM, and notice that that toggles the expansion of just those selected line of codes. Okay, so there's support at a high level using the menu items and keyboard keys for working with outlining.